Okay, guys, let's start. So, good afternoon, everybody. So what I did last time, I explained shift and to rotate instruction. Okay, so I explained shift and rotate instruction. I said we have two kinds of shift. We have shift right and left. Also, we have arithmetic and logic shifts. And then after that, I explained rotate instruction. And last time, yeah, so this is arithmetic shift. And the coming lab is going to be about shift and rotate instruction. Also, it's going to have logic operation. So also last time I started to explain Boolean logic operation. And I told you we have instruction to do three types of operation. How can you do AND or XOR? Bit by bit. So you can do bit by bit and bit by bit, bitwise. We call it bitwise or bit by bit logic operation. So I'm going to teach how can we do AND, how can we do OR, how can we do XOR. More importantly, I'm going to explain how can you use them. How can you use it, okay? So last time I explained, number one, this is how AND works. 0 and anything, you should get 0, okay? 1 and anything, you are going to get the same X here, okay? So that's why I told you AND is going to be used if you want to clear some bits, okay? Because based on what I explained here, if you see here, guys, if you want to clear a bit, okay, that's what I said last time. You have, just give me 1 second. So what I said last time, if you have a byte, sometimes, so I have a byte this way. Sometimes I want to clear 1 bit. For example, I want to clear this bit, and I don't want to change the other bit. Don't change, okay? So sometimes I want to do something like that. As I told you before, for example, this LED, that's what we're going to do in chapter 3. These LEDs are connected to port B. Port B is a byte. You got what I'm saying? It's just a byte. So all what you have to do, if you wanna turn one LED off, you have to put 0 here in this bit. Because once you put 0 here in this bit, as I said, it's 1 bit. Once you put 0 here in this bit, so this bit is connected to a pin. So this pin is gonna have 0 volt, and 0 volt is gonna turn the LED off. You got what I'm saying? So sometimes you need to set the bit so that you can turn the LED on. Sometimes you need to flip. So three things you can do actually to manipulate. This is the main idea. The main idea is very simple. You have a byte, okay? I want to manipulate some bits, and I don't want to change the other bits. What do you mean by manipulate? I mean 3 things: set, clear, XOR, flip. Okay, flip. Sorry, flip is done by XOR. So now, as I said, how can you do that? How can you do that? I'm going to give you a byte. You have to do some operation on this byte so that some bits you are going to manipulate and you're not going to change the other bits. How can you do that? That's what I'm explaining. Number one, as I said, if you want to clear some bits, you have to do logic AND. If you want to set some bits, you have to use OR, logic OR. If you want to flip some bits, so in this case, you have to use XOR. And why? I'm going to tell you why. Simply because in case of AND, okay, guys, if you put 0 here in 1 bit, so whatever is there, you are going to get 0. That means if I want to clear this bit, so I have to do AND operation with 0 here, because the result has to be 0 regardless of whatever is there. That's okay, but also that's not enough. Also, I don't want to change the other bits. So I want to clear this one, but I don't want to change the other bits. It's already there. How it is already there? If you see how AND works, if you put here 1 and 1 and x, I'm gonna get x. So 1 is not gonna change. So all what I have to do, I have to put 1s here. Is that okay, guys? So by this way, this part is gonna come to here. No change. Okay? I give you here one example for 1 bit. 1 bit. What if you want to change 2 bits, 3 bits, 4 bits? It's the same idea, right? So you just put 0. The bits you want to clear, just put 0. The bits you don't want to change, just put 1s. Is that okay? So I'm gonna do an operation, and then this result is gonna be stored in port B or wherever you wanna store. Is that okay? Actually, this is how it is. For example, this is the value of port B. So I'm gonna do some operation on this one, and the result has to go to port B, or maybe this is a byte in memory or whatever. Okay. So here, is that okay, guys? Any question? Same idea. How can we use OR to set some bits? Okay. So now I told you why sometimes we need to set some bits. Why sometimes we need to clear some bits. For example, you want to turn the LED on, so you need to set the bit. Okay. So how I can set some bits? Okay, and also at the same time, you should not change the other bits. How I can do that? That's very easy. Okay, so all what you have to do is, for example, I wanna set this bit. Okay, also I don't want to change here, no change. So the way I'm gonna do it, okay, if you look how OR works, if you put 1 here, regardless whatever you have here, I'm gonna get 1. Okay, so I'm gonna put 1 here because this bit has to be 1. Is that okay? And also, if you see how OR works, if you put here 0, you are gonna get x. So 0 means no change. 0 is not gonna change. So I'm gonna put here 0s. Very easy, right? So the bits you wanna change, you wanna set, you have to put 1. The bits you don't want to change, you have to put 0. So by putting 0, you are gonna, and then you have to do here OR operation. Is that okay? Here is different, right? Here one is not change. Here 0 is not change because the operation is different. Let's see how can you flip some bits. So also same idea. I'm gonna use the same concept. Okay, so I wanna flip this bit and not change those other bits. What should I use? If you wanna flip some bits, you have to use XOR. How I'm gonna use XOR? Okay, let's see how XOR works. Very simple. XOR should work this way. This is how XOR works. If you put 1 here, x, I'm gonna get x prime. Is that okay? X prime means 1's complement to this bit. So if this bit is 0, I'm gonna get 1. I'm gonna get 0. Is that okay? Same thing. If you put here 0, XOR x, I'm gonna get the same x. This is how XOR works. So it's very simple. If you wanna flip 1 bit, so you have to do XOR. But what number I have to use? The bits I want to flip, so I have to put 1. The bits I don't want to change, I'm going to put 0s. Is that okay? By this way, this one, if this one is B node, I'm going to get B node prime here and then no change here. Any questions? Okay. One more thing, guys. So here, actually, we can use logic operations. We can use logic operation to do one of 2 things. You can manipulate some bits as I explained. So you can manipulate bits, okay, as I explained. Also, you can use the logic operation to check if some bits are 0 or 1. Okay. And again, how this one is useful, as I told you before, you have a pin here. This pin is connected to a switch, okay? And internally, this one should connect it to a bit, okay? If this bit is 0, that means the switch is connected. If this bit is 1, means the switch is disconnected. So I have a byte. I don't want to manipulate the byte. I don't want to check. I don't want to change the byte. All what I'm gonna do, I wanna check 1 bit or some bits in this byte without changing anything. I wanna see if this bit is 1 or 0. Why? Simply because this bit can be connected to a switch. I wanna know if the switch is connected or not. Also, I think as we did in the last lab, you wanna know if this number is odd or even, right? You need to check some bits. So sometimes you need to check some bits, okay? But listen to me. So you are telling me I can use logic operation to check some bits? The answer is yes. But we already did that. Why you teach it again? Because we already did it, right? We did it in the last lab. We did it using branch if clear, branch if set. That's true. We did it, right? Using branch if clear. So this one is going to check some bits and it's going to branch if these bits are ones or zeros, right? Clear or set, right? Yes, yes, we did it. But I told you before, this one has a problem. The problem in this one is short and we don't have a long version of this one. Okay, that's why I'm going to explain another way. Again, what I'm saying, if this one is enough, you can use it all the time. That's okay. But you may have a problem if you use this one. The problem is that's why I'm going to teach another way, because this one is okay for short. If the branch is short. If the branch is long, it's not going to work. Is that okay? So now how I can do the same thing like branch if clear, branch if set, how I can do the same thing using logic operation, and how I can make it long. Okay? The idea is very simple. I'm going to tell you how. Look here, guys. If you want to check some bits, here you have to use AND, logic AND. I'm going to tell you how. Okay, for example, I have this bit here. I want to check if this bit is 0 or 1. So I don't care about these bits. I just want to check this one. Is that 0 or 1? So I want to just check this bit. Okay, guys? Look at the idea. The idea is very simple. Look here. The bits. So here, I'm going to put zeros here. All of them are zeros. Okay? Look at the logic. Why you put zeros? Because if I use AND, 0 and anything, so I'm going to get 0 here. Yes. So the bits I don't care about it, the bits I don't want to check, I want to clear all of them. That's okay. So now I don't care about this bit, I want to check this bit. Okay? Again, I'm explaining this example in 1 bit, but still you can extend it to more than 1 bit. Okay? So here I don't care about this one, so I'm gonna clear them. I'm gonna zero them as you see. So all of them are 0, so I'm gonna put 0 here. Okay. But the one I care about, or the bits I want to check, I'm going to use number 1, because 1, and this is B note, so I'm going to get here B note, right? So if B note is 0, I'm going to get 0. B note is 1, I'm going to get 1. Okay. So now look at the number. This number. I'm going to look at the byte. I'm going to look at the byte as a number. Okay. If this byte, now I'm going to check this byte. If this byte equal to 0, or if the 0 flag equal to 1. That means the byte is 0. What it means? What it means? If after you do this AND operation, you found the 0 flag is equal to 1. That means all these bits are zeros. That means B note is equal to 0. Otherwise, if the 0 flag is equal to 0, that means the result is not 0. That means this bit B0 is not 0, right? So that means B0 is 1. Any question? Is that okay, guys? You got the idea? Yes. And now you can use branch if equal, or you can use long branch of equal, or long branch if not equal. Okay, I'm going to give you example now, but this is the main idea. Is that okay? So let me tell you the conclusion, and then I'm going to give you. I'm going to teach you what instruction we have, and then I'm going to teach you examples, and that's it. So we're going to done with this section. Okay. So yeah. So this is what I said here, guys. What I said, if you want to manipulate some bits, set clear flip. So you have to use logic operation. Also, same thing. If you want to check some bits, you can use branch if clear, branch if set. Okay, and I said this is useful if you want to, for example, if you want to know if this pin, which is connected to a switch, is 1 or 0. That's what I explained. Here I'm explaining how can you clear some bits. Here I'm explaining how can you set some bits using OR. How can you flip some bits? Okay. Here also I'm explaining how can you check a bit if this bit is 1 or 0. Okay. Now I'm going to teach what logic operations we have. For AND, we have only 3. We have 3 instructions. We have AND A, and then you can put here a memory location or immediate value. So what this instruction is going to do, A should equal A and memory location or immediate value. All the instruction we have here for bytes. And this AND is bit by bit, bitwise. Is that okay? Second one here, we have AND B and memory location or immediate value. It's the same thing. So B should equal B and memory location or immediate value. We also have AND CC. CC is the flag register, CCR, okay? So here here CCR, which is the flag register, should equal the flag register and memory location or immediate value. Okay, so all what we have here for bytes. Is that okay? Okay. What if I want to do AND for a word? What would I do? For example, I want to do AND register D, for example, with number 3AF2. Any idea? I want to do AND between register D and 3AF2, for example. Any idea?
You have to use A and B.
That's true. That's true. So all what I have to do, actually, it's very easy because register D is actually B and A. Is that okay? So I'm gonna do B with this number and the A with this number. That's true. So I'm gonna use these two instructions. There is no carry to worry about, right? So this idea here is different. There is no carry, right? So I can separate it. I can separate the AND. Yes. Okay. For OR, we have exactly same instruction for OR. So we have OR A, okay, with memory or immediate value. We have OR register B for memory. So the same thing exactly, but this is for AND, this is for OR. And all of them for bytes, and also the same idea. If you wanna OR a word, you can do the same thing as I explained. You can use two instructions as I explained here. Now I wanna explain XOR. So XOR, for XOR, it's the same instruction, but actually you don't have the last one here. So actually for XOR, we have only two instructions for XOR. Okay, so you can say XOR A and memory or immediate value, or XOR B. Okay, that's all what we have. Is that okay? Any questions? So now I'm going to give you examples. I'm going to teach in these examples how can you use this logic operation to do two things: manipulation to some bits or check some bits. By the way, in next chapters, especially in chapter 3, all the time we're going to check some bits or manipulate some bits. Okay, it's because this is very useful. We're going to do it all the time. Okay, so let's have some examples here. The first example I want to teach here. Clear the upper 4 bits on the byte at this memory location 56. So I want to clear the upper 4 bits in this byte. Is that okay? For sure, if you want to clear some bits, I have to use AND operation. But for sure, I cannot do AND operation to memory location directly. Okay, that's why here I have to read, as you see here, guys. I have to read this byte first. Okay, so I have to read this byte first. So I put it in A. After I read the byte, so now I'm gonna do AND operation with this number. So the bits I wanna clear, which are the upper 4 bits, 0, 0, 0, and bits I don't want to change 1, 1, 1. Is that okay? So, and then now I cleared the upper 4 bits, but be careful. The result now is in A, so I have to return it back to the memory location. I told you before, many students or some students forget the last step here. To me, you already did the difficult part. You just lose easy marks. You have to focus, right? So in exam, I get surprised when I see some students. You already did the difficult part, but you forget to do. So as an instructor, because the answer is not completely true, I have to deduct some marks. But you have to be careful. Okay, that's very easy. You should not, because the result here is in A. But here I want to clear in this memory location, so I have to return it back. Any questions? Okay, guys. So let's have another example. Another example here, I want to set bit number 7 in the byte at location number 10. Okay. So the way I'm gonna do it, guys, is again, I'm gonna read this byte, and then because bit number 7, which is this one, this bit, I wanna set this bit. So I'm gonna put 0 here, and then I'm gonna put I'm gonna put 1 here, and then I'm gonna put 0 everywhere. So I can put hashtag %, and then I put a binary number this way, or you can put hashtag and you put it in hexadecimal this way, whatever you like. Okay. But again, then I'm gonna return it back to here. Any questions, guys? Is that okay? So here in this example, I'm showing you how can you use AND or OR operation to set or create some bits. Okay. Again, there's another thing here, which is the same thing. How can you flip bit number 7 in byte at 10? It's the same thing here. So I'm gonna get number 10 here, and then I'm gonna put here 80, which is 100000. Okay, and then I'm gonna use XOR because I want to flip this bit. I don't want to change the other bits. And then I'm gonna return it back to here. Okay, guys, any questions? Okay. Now, I'm gonna tell you something else here. Look here, guys. I told you OR can be used if you wanna set some bits. AND is used if you wanna clear bits. XOR is used if you wanna flip some bits. And explain how can you use this logic operation to do it. Okay, that's what I explain. Now I'm gonna explain two new instructions. They are very useful instructions. I recommend you to use them because it's much easier than what I did. Okay, these instructions are here. If you want to set some bits, you can use OR, as I explained, or you can use another instruction. We call it bit set. So there is another instruction I'm gonna explain. This instruction is called bit set. This instruction is used if you want to set some bits. Is that okay? This is exactly similar to the use of OR. Okay, same thing for if you want to clear some bits. If you want to clear some bits, you can use AND, as I explained, or you can use another one. It's called bit clear. Is that okay? They are the same? Yes, they are exactly the same. I recommend to use this one because this one can be one instruction. But if you use OR as a bit clear, usually it's 3 instructions. So this one is much better. Okay? But for XOR, if you want to flip some bits, you have to use XOR because we don't have another instruction here. So you have to use XOR. Is that okay? Okay. Now tell us how can we do bit set or bit clear? What is the instruction here? Okay, what is this is the format of the instruction, and it's very close to branch if clear. Okay, I'm gonna come to it now, but so now bit set. You can say bit set or you can say bit clear. Okay, and then you have to put here memory location, memory address. You have to tell me which byte. I have to set bits in which byte, so you have to tell me which byte. Also, you have to give me a mask. So this one you have to tell me which byte. This one you have to tell me which bits in this byte you want to clear or you want to set. Is that okay? So this mask is similar to the mask I explained before in branch if clear or set. It works this way. So I have a byte here, guys. If I want to set or clear the bits I want to set, you have to put 1 all the time. I know it's a little bit confusing. Listen to me. In case of mask, okay. In case of mask, just you have to tell me which bits you want to set or clear. That's it. Is that okay? But that's why it's always, even if branch if clear, it's the same thing. Always we use 1 just to tell me which bits. Is that okay? So always we use 1 for the bits you want to set or clear. Okay? But here the idea is completely different. Here the idea is completely different because here I'm doing OR operation. If you give me 1 means I'm gonna set. Here 0, zero here means clear. You got what I'm saying? So what I'm saying here, guys, is if you use a logic operation, you have to think, should I put 0 or 1? In case of clear, you have to put 0 for the bits you want to clear, right? In case of if you want to set some bits, you have to put 1. You have to think, okay? If you want to use OR operation. But in case of bit set or bit clear, don't think. Just tell me which one, and the instruction is going to take care of the rest. Okay? So the instruction itself is going to use OR, it's going to use AND, and it's going to use the correct or the number that should be used with this logic operation. Okay? So what I'm saying, in case of bit set or bit clear, always in case of mask, the purpose of the mask just to tell me which bits I have to work on. Okay. So let me give you example here, guys. I explained this example. How can you clear the upper 4 bit? I told you are gonna put 0, 0, 0, 1, 1, 1, 1 because I wanna clear these ones. I don't want to change these ones. Okay. So if I do the same thing using bit clear, so that's why I like and I recommend a bit clear because it's just 1 instruction. Look here, guys. Here I did 3 instructions. If I use bit clear, I'm going to use only 1 instruction. It's much easier, right? So I'm going to use only 1 instruction. So here I'm going to say bit clear, and then here this is the memory location, and now this is a mask. So in this mask, I have to tell you, I'm asking to clear. So here the bits I want to clear, I have to put 1 here in the bits I want to clear. Okay. The bits I don't want to change, I'm going to put 0s as you see here. Okay, guys, any question? Same thing here, guys. Let's see this example. here I explain this example. How can you set bit number 7 using 3 instruction using OR operation? Now I can do exactly same thing using bit set. Okay. So here in bit set, you have to put the byte here, as you see. You have to put the byte here, and then you have to, this is a mask. In this mask, you have to tell me which bit. You have to put one in the location of the bit you wanna set. Any question? Any question here, guys? So I said if you use logic operation or use bit set or bit clear, you have to put a memory here. This memory can be any format of the memory. So it can be 0,x, can be any format, right? Any question? What I want to tell you here in this slide, guys, because these two instructions are very, very close to each other. Look here, and very close in the writing, the spelling. Okay. So this one is bit set, bit clear. Here. This one, these two. Also, before I explained branch if clear, branch if set. That's what I explained before, and that's what used in the last lab. Look, the spelling is very close, but the operation is completely different. So this one is gonna branch, okay? This one is gonna branch if it is clear or set. But this one is gonna manipulate bits. So this, I can say this way. This one should manipulate bits. But this one should check bits. You wanna check some bits, and you wanna check, you wanna branch or not. Is that okay, guys? Any question? Okay. Now what I'm gonna explain. So now I am done with manipulation. So now after what I explained, let me tell you the conclusion of what I explained in one sentence, okay? Or give me 2-3 sentences. So it's not, so it's gonna be too short, but let me put this way. If you wanna manipulate some bits, guys, manipulate means set, clear, flip, okay? If you wanna do that, you can use AND to clear or to set some bits, and also you can use XOR to flip some bits. Is that okay? This is one option. The other option is you can use bit set and bit clear to set some bits and to clear some bits. We don't have bit flip or bit XOR. We don't have this one. Okay, so if you want to flip some bits, you have to use the XOR operation. Okay, but that's it. Okay, you should learn how can use it. I recommend to use this one. There is no, I don't see any advantage of using OR. Logic operation over these two. That's why I recommend this one all the time. It's just very short, one instruction. Okay. Now I'm gonna move to how can you check some bits, and I already explained it before using branch set and branch clear. I explained it before, but now I'm gonna I told you before. I'm gonna tell you my opinion. My opinion, if branch set and branch clear is working, it's okay for you. My opinion, use them. They are easy. Just use them. I'm okay if it works. But as I told you before, sometimes it doesn't work because these two instructions are short. Sometimes you wanna make a long branch. Okay. If this is the case, you have to make a long branch, and these two are only for short. If this is the case, you have to use AND operation, and that's what I'm gonna explain right now. How can you use AND operation? But I explained the concept. Okay, so the concept, as you see here, guys, I want to branch to next if bit number 0 of byte at 10 is 0. Okay, so I want to check bit number 0, which is the first bit here. I want to check the first bit here. Okay, and I want to branch to next if this bit is 0. Okay, so if you use branch if clear, you can do it this way, as I explained to you before. I can say branch if clear, and this is the byte, and this is your mask. This is the mask, comma next. Okay, that's what I explained. That's what you did in the last lab. Okay. Now I want to explain the other approach. If I don't want to use this one because it's short, I want to make long. What would I do? As I told you, we're going to use AND operation. How? As you see here, guys. Because I want to check this bit. I'm going to put 1 here, and then I'm going to put 0 everywhere. So the result should be, this is the result, this is the byte, is this way. And then after I do this AND operation, I'm gonna look at the 0 flag, right? I'm gonna say branch if equal, if the 0 flag is 1, what it means? It means the result is 0. That means this bit, the bit I'm checking is 0, right? And branch if not equal, if the zero flag is 0, right? So that means this bit is 1, it's not 0. Okay, that's exactly what I'm going to do here. So this instruction, you should be familiar with these instructions. That's what you did in the last lab. Should be equivalent to these 3 instructions, but this 3 instruction can make long branch. This one can make short branch. So let me show you how it works. Here I'm going to read a byte. I'm going to read a byte at the memory location number 10. Then I'm going to do AND operation. I'm going to do AND operation with this number. Okay, guys? So 1, 0, 0, 0, 0, 0. And then if equal, go to next. Because if it is equal, that means the 0 flag is 1. And the 0 flag is 1 if bit 0 is 0. Right? So here you are going to branch if this bit is 0. So if I want to branch if this bit is 0, I'm going to say branch if equal. If you want to branch if this bit is 1, so I'm going to use branch if not equal. Any questions? Any question, guys? Okay. So last instruction I'm going to teach here, I just have more examples here, just a couple of more examples. Some examples here are somehow interesting, and then if I think I still have time, so I'm going to we're going to start the stack today. But let me finish here. So look here, guys. There is a little problem here. What is the little problem? It's not a problem. Do you remember what is the difference between subtract and compare? Okay, so compare and subtract, right? So both of them are doing subtraction, update the flags. But compare is not going to store the result anywhere because actually I'm not interested in the result. I just want to update the flags, okay? We're going to use the same concept here. We're going to use the same idea here. So here if you use AND, so you are going to do AND operation. You are going to update the flags. Number 2, you are going to update the flags. Number 3, you are going to store the result in A. Is that okay? So what if do I need the result? So do I interested in the result? No, I'm not interested in the result. I just want to update the flags. Okay, that's why they invented a new instruction. This new instruction is gonna do AND operation, but it's not gonna store the result anywhere. Similar to the idea of compare, exactly the same thing. What this instruction? Yeah, these are the 2 instructions we have here: bit A and bit B. Okay, 2 instructions. So if you say bit A, and then you put here memory location or immediate value, and if you say AND A, memory location, immediate value, what is the difference between them? So the difference between them is exactly the same idea like subtract and compare. It's the same idea. I'm going to tell you how you see now. So what this one is going to do, this one is going to do AND operation. It's going to update the flags, but it's not going to store, it's not going to change A. It's not going to store the result anywhere, okay? And this one makes more sense because I'm not interested in the result. I just want to update the flags because I want to check. I want to do comparison or check. Okay, but if you do AND, so actually it's going to do the same thing. So but it's going to do the same thing like this one, but this one is going to update A. Okay. So anyway, if it doesn't matter, listen to what I'm saying. If it doesn't matter to you, if you change A or not, if it doesn't matter, you can use AND. And that's it, okay? It doesn't matter, right? But if it matters, if I'm gonna use A later, and I don't want to destroy A because I'm gonna use it later, so it's smarter to just use this one. So you can check A without destroying the value of A, okay? So same thing for B. So we have A and B, bit A and bit B. Any questions? Okay. So all what I have now, it's just examples. So let's see this example. Branch to next if either B0 or B1 in memory location number 10 is 1, either. Okay. So that means here this is the byte number 10. Here I want to check these 2 bits. Okay. So I'm saying here if either is 1. Okay. So here I'm gonna make 2 cases. 0, 0 is 1 case. And then 0, 1, 1, 0, 1, 1, okay? So the branch has to be taken in this case, right? Either B0 or B1. Either B0 or B1 means it should be one of this case. At least one of them is 1, that's what I mean, okay? So here, so in this case, if these 2 bits are 0, then the branch should not be taken. If any one of these values, the branch should be taken. Is that okay? So how I can do this way? Look here, guys. I'm gonna read the byte. I'm gonna put it in A, and then I'm gonna do AND operation bit A, and now I'm gonna check these two bits. So I'm gonna put one here, and then based on this one, if the zero flag equal to 1, okay, that means these two bits are 0, 0. Otherwise, if any one of these values, the zero flag should be 0. Okay, that's why I'm saying, look here, guys, if it is not 0, if it is not equal, okay, if the zero flag is 0, come to here, come to next, because this should be one of these cases. Okay, but what if the zero flag equal to the to 1? So in this case, the branch is not going to be taken, and then it's going to come this way. Any questions? Okay, guys. So it's the same idea if you wanna, but for sure this branch can be long, but it's the same idea. I can replace this instruction with branch if clear. But I have to change it a little bit, because branch if clear, for example, here I'm gonna say which memory location is location number 10. What is the mask? So the mask should be 0, 0, 0, 0, 0, 0, 1, 1. And then I'm gonna say here to end. So go to some location, it's called end, okay? That means here I'm looking for this case, 0, 0. So if the two bits, if these two bits are 0, so I'm gonna go to end, and next has to be here. So this is next has to come to here. Is that okay? Because if these two bits are zeros, both of them are zeros, I'm gonna skip this part next. And otherwise, anything else, like one of these three cases, I'm gonna come this way. Any questions? So here, just what I'm saying, if you say branch if clear, so this one is gonna branch if the two bits are zeros. Otherwise, it's not gonna be branch. Branch if set, this one is gonna branch if the two bits are set. Otherwise, it's not gonna be branch. Any other case, because total we have 4 cases. Okay, any questions? Okay, so let's have more examples. Now, I wanna branch if B0, listen to me because this is very confusing, very important. Listen to me, guys. Okay. What I explain right now, if you use AND, okay, to check some bits, or if you want to use branch set or branch clear, what I explain right now is you can check if some bits, all of them are ones, or all of them are zeros. You got what I'm saying? Branch of set, this one is going to branch if the bits you want to check, all of them are zeros, or all of them are ones. Is that okay? But this is not always the case. For example, this is a very good example. What if I wanna branch if these two bits are 1 and 0? You got what I'm saying? So it's not all of them are zeros. It's not. So now I'm interested in 2 bits. Okay. If the 2 bits are zeros, that's easy case. I'm gonna use branch if clear. If the 2 bits are ones, that's very easy. I'm gonna say branch of set. But now no, I'm saying this one has to be 1. This one has to be 0. Is that okay? In this case, you cannot use 1 instruction, you have to use 2 instructions. Is that okay? So I'm going to use 2 instructions. Every instruction is going to look at 1 bit. Because think about it. The tools we have is going to branch if all the bits are zeros, all the bits you want to check are ones. Is that okay? Clear? So in this case, still you can do it, but you have to use 2 instructions. Because I have to use 1 instruction to check each bit. That's what I'm going to do now. Okay? It's like you know when we did condition before, like or, like if this one or, like or relation conditions. So let's just check how I'm gonna do it. So here, as you see here, guys, number 1 here, I'm gonna check this bit. I'm gonna say branch if set. So if this bit is 1, go outside. I'm done. I don't need to continue. Is that okay? So here, if this bit, if bit 0 is 1, just to go outside, I'm done. Okay? I'm not gonna, because it's already, if one fails, if one check fails, so it's not 1, 0. Okay? So else, this branch is not going to be taken, if B0 equal to 0. So now this one is okay. The first one is okay. Now I have to look at the second one here. I have to look at the second one and here. So here I'm going to look at the second one. I'm going to say, if the second one is 0, okay, go outside. So if this one is 0, come outside. Okay. So for sure, it's very clear. The only way to come to here, this branch should not be taken and this branch should not be taken. And the only way that these two branches will not be taken if it is 0, 1. Is that okay? Any question? Yes?
Shouldn't the mass for the branch clear, shouldn't the line be over?
So your question is that branch is clear?
Yeah,
The mass has to be different?
Yeah.
No? No? Okay, this is a very important point, and I'm sure some of you will be confused, okay? If you use AND or, it's going to be different from branch set and branch clear. In branch set and branch clear, okay, the mask is just, you have to, in the mask, you have to tell me which bits you want to branch, if they are clear or they are set, okay? Just tell me which bits, okay? It's not your business if I'm going to use AND. It's not your business if I'm going to use or whatever. It's just tell me which bits, and then the instructor is going to do the operation. You got what I'm saying? That's why here always the bits when I check, you have to put one. Stays either if it's set or clear. Is that okay? But if you use AND operation, if you use, for example, if you want to set some bits or you want to clear some bits, here the case is going to be different. Or even if you use AND operation, if you want to use AND operation, the bits I want to check, I have to put 1 and 0 all the way. So if I want to check this one, so it's going to be similar to this one. I think what's confusing you is you are confused between what confused you if you want to set some bits or I want to clear some bits, because this is different. For example, if I do AND operation to clear some bits, the bits I want to clear I have to put 0. I do functions, I have to put 1s. Okay, if I want to set some bits, I have to use OR, I have to put 1 and I have to put 0. Maybe this is what confusing you. You got what I'm saying? So let me tell you the conclusion. The conclusion is that in case of branch set or branch clear, okay, the mask always the bits you want to check, okay, just to put 1s in the locations of these bits. Okay. Does that answer your question or? Anyway, let's have another example, and this is very interesting example, and it's going to be the end. So let me see, it's somehow fancy example, so I'm going to tell you what I mean exactly. I'm going to come to the picture here. So we have a car. Yeah. So here what I want to do, guys, so here, it's like we have a car here, and this car, we have a byte here. We have byte. We assume this byte at the memory location 000, as you see here. We assume here, okay, this one, this bit. So I think this bit should be 1. If let me check. I think it's written somewhere here. Oh yeah. So here, it's I have a byte. This byte at memory location 1000. Bit number 5 is going to tell you if the right door is open or closed. Bit number 6 is going to tell you if the left door is open or closed. Is that okay? And this bit number 1, this one can turn the cabin light on or off, right? So here, if you want to know if the right door is open or closed, you can check this bit. If you want to know if the left door is open or closed, just check this bit. Okay, if you want to turn the cabin light on, just put 1 here. If you want to turn the light off, just put 0 here. Is that okay? So here in this example, I'm going to show you in a very practical example, a very interesting example, how we're going to check some bits and set or clear some bits. Okay, so I'm going to give you several cases here. I'm going to tell you if the right door is open, okay, turn the light on. If it's closed, turn the light off. Okay. Or I'm going to tell you if the 2 doors are open, turn the light on or turn the light off. So I'm going to give you some example here. So in this example, I'm going to use manipulation, bit manipulation, to turn the light on or off. Also, I'm going to check bit check to check some bits to know if the door is open or closed. Okay, so together, I'm going to put them together. You'll see now. This should be the last example. After that, we're going to start the stack. So here, so this is the byte I told you about, guys. So I have here the bit number 1. As you see here, bit number 1. This bit number 1 is connected to the cabin light. So if you want to turn the cabin light off, you have to put 0 here. If you want to turn the cabin light on, you have to put 1 here. Is that okay? If you look at these 2 bits here, guys, these 2 bits, as I said, if this bit number 5, if it is 1, that means the right door is open. If it is 0, that means the right door is closed. Okay. Same thing for number 6, but this is for the right door. 1 means the left door. The left door is open, 0, the left door is closed. Any question? Again, if they are updated automatically, this is hardware. Once you open the door, the sensor is gonna put 0 on the pin of the microcontroller, or it's gonna put 1, and then this pin is gonna change immediately. It's not your job. You got what I'm saying? So this number is a hardware. Once you open it, the pin. So what you see here, actually, you see the status of the pins. Okay, this pin should come from the sensor. There should be a sensor. This sensor should be connected to the door. If the door is open or closed, for example, if the door is open, so the sensor has to put 5 volt on the pin. Okay, if the door is closed, it has to put 0 volt. Okay, sensor. Okay, and here, this is the software world. Here in the software world, I don't care about what happened in the hardware. I just have a byte, and I need to check the byte. You got what I'm saying? This is a software world. So anyway, let's see the first example here. In the first example, I want to turn the cabin light on if the 2 doors are open. So if the 2 doors are open, I want to turn the light on. Otherwise, turn it off. You got what I'm saying? So the only way to turn the light on, for sure, this maybe doesn't make sense, because usually if 1 door is open, okay, but I want to program it this way for some reason, okay? Just I want to practice. So I'm going to tell you the only way to turn the light on is the 2 doors, both of them has to be open. Is that okay? Otherwise, turn it off. So the way I'm going to do it, as you see here, because I'm going to say, so now I want to check these 2 bits, right? So here, I'm going to say branch F set, 0, 0, 0, and then I want to check these 2 bits. So if these 2 bits are set, 1 and 1, what it means? It means the 2 doors are open. The 2 doors are open. So what should I do? So now I have to go and turn the light on, okay? So now I'm going to look at these 2 bits. If these 2 bits are 1 and 1, so now I'm going to go to a location. This location is called light is on. So, okay? And then once I come to here, I have to turn the light on. How can you turn the light on? That's very easy. All what you have to do, bit set. You have to bit set this bit. Okay, that's okay. Okay, guys? What if, so I'm gonna jump into here, if the 2 bits are 1, 1. What if it is anything else? Anything else means one of these 3 cases, 1, 1, 1, 0, 1, 0, whatever, okay? So any one of these cases, okay? What should I do? The light has to be off. So once I come to here, I'm gonna use the same instruction here, but this is bit clear. So I'm gonna turn the light off. Also, don't forget this one. This is a common mistake between students. So once I have to skip this one. You got what I'm saying? Let me tell you the conclusion. The conclusion is I'm gonna check the 2 bits, and now I have 2 cases. One case, 1, 1. The other case, 1, 0, 0, 1, 1, 1. So this is 2 cases, right? If it is 1, 1, so I'm gonna come to here to turn the light on. And this is the logic I wanna program. Is that okay? If not, if anything else is gonna come to here, and then I'm gonna turn the light off, and then I have to skip this one. Otherwise, you know, it's disaster if you forget this one. You know what? If I forget, that's why I'm telling you, this is what we call logical errors. Okay, you run the program, then the result is not as you expect. You know, I need someone to tell me if I forget this one, what would happen? All the time you turn the light on. Right? So no matter what is it, so if this one, I'm gonna turn it on. If see one of these, I'm gonna all the time I'm gonna turn it on. Okay, so for sure it should be this. Any questions? Let's have more examples on the same case. But I wanna program different logics. So what I'm gonna do now, I wanna program different logic. Let's see the logic here. So here, I want to turn the cabin light on if either door is open. If either, okay? And maybe this is the more logic, or that's what actually happened in reality. In reality, if any door is open, the light should be on. That's what I want to program here. So the only way to turn the light off, so if the 2 bits are 0, 0, I'm gonna turn the light off. If anything else, I'm gonna turn it on. Is that okay, guys? So let me show you what I did here. What I did, again, branch if clear. I'm gonna look at these 2 bits. If the 2 bits are 0, 0, if these 2 bits are 0, 0, okay, that means I have to turn the light off. So I'm gonna come to here, and here I'm gonna turn the light off. Branch if clear. Okay. If it is any other case, any one of these cases, so I'm gonna come to here. Once I come to here, I'm gonna turn the light on, and then I'm gonna skip again. Are you okay with the logic? Very important to do something as I did here, okay? So this branch is gonna be taken if the 2 bits are 0, 0. I'm gonna come this way if any other value, like this one. So if it is any one of these values, I have to turn it on, and that's what I did here. Is that okay? Any questions? So should be very easy for you. How can you check some bits? Very easy. That's what we're gonna do in the coming lab, also in the coming quiz. So in the coming quiz is gonna be about shift, rotate. Also it's gonna be about logic operations, okay? It's very easy for you to check some bits. It's very easy for you to set or clear some bits. Is that okay? I remember in the assignment, we have, not only the assignment, you will need it in the coming lab as well. I remember in the assignment, I'm gonna give you, this is 1 byte and this is another byte. If I tell you, I need someone to tell me, if I wanna copy a byte to byte, that's very easy, right? Transfer, can copy byte to byte, that's very easy, right? What is not easy is, if I wanna copy bit number 3 here to bit number 5 here, copy. How can I copy 1 bit to 1 bit? Transfer doesn't do that. Don't think about transfer. Transfer copy byte to byte. Now I cannot copy bit to bit. So if this is 0, I have to write here 0. If this is 1, I have to write here 1. Anyone can think about it? Yes. Raise your voice.
You use OR to get the first bit, to select that bit, and then use AND to write the second one, or vice versa.
I have to do 2 things, right? I have to check, and then I have to do manipulation. So the first step, without details, I have to check this bit, a check bit. Okay, and I already explained how can you check some bits, right? So you have to check this bit. If this bit is 0, so I have to write 0 here. So I have to clear 1 bit. I already explained how can you clear 1 bit. If it is 1, so you have to set here. Get what I'm saying? So you have a byte, number 1, I have to check this bit. Okay? If this bit is 0, I'm gonna write set. Sorry, if it is 0, I'm gonna clear. If it is 1, I'm gonna set. Okay? You already, without details, I already explained how can you check some bits, how can you set or clear some bits. Is that okay? You need it in the coming lab in somewhere, and I'm gonna tell you why you need it. Let's have more examples here. I think I still have 1 more example or so. Yeah, only 1 example. So here in this example, I want to turn the cabin light off. So I want to use a different logic, okay? So I want to turn the cabin light off if both doors are closed. So you got what I'm saying? The only way I want to turn it off, I want to turn the cabin light off if the 2 doors are closed. Closed means 0, 0. Okay, so bit number 5 and 6 should be 0, 0, okay? Let's see how I can do it. Number 1, I'm gonna check these 2 bits. If these 2 bits are clear. So if they are 0, 0, I'm gonna come to here to turn the light off. And this is how I can turn the light off. I'm gonna say bit clear, and then I'm gonna turn the light off. So I'm gonna clear this bit to turn the light off, okay? Otherwise, if it is anything else, anything else, okay, you can skip, or maybe it's not clear in the question, but if you wanna turn it on, you can turn the light on. So here, the way I did it right now, I'm gonna turn it, I'm gonna close, I'm gonna turn the light off if both are closed, but anything else, I'm not gonna do anything, okay? Just I'm gonna skip. Okay, if you wanna make the logic this way, it's okay. If you don't want to make the logic, if you wanna turn it on, you can simply put here bit set, and then you can put here 0, 0, 0, and then you can put 0, 0, 0, 0, 0, 0, 0, 1. Sorry, it's 1, 0. Any question, guys? Okay. Any question? Again, the conclusion is that. So the conclusion of these two sections, the conclusion is that I thought you should learn how can you check some bits, okay, using branch set or branch clear, and use it if necessary, if needed, in case of long branches. You should know how can use AND to check some bits and to branch for long branches. This is number one. Number two, you should learn how can you set some bits in a byte, how can you clear some bits, how can you flip some bits. We're going to do it all the time. That's what should you learn. Okay. Before I teach stack, I think I have something here about the coming lab. The coming lab, I think I told you last time it's 8 programs. When I checked, originally it was 8 programs, and then I reduced them to, I think, 6 small programs. Okay, they are small programs. So one of the program here is, I'm telling you, register A, I want to multiply it by 9. I want to multiply register A by 9 using shift operations. Okay. This is a little bit confusing because if you tell me multiply by 2, that's easy. I'm going to do 1 shift left. If you want to do, if I shift again by left, I'm going to multiply it by 4. If I shift again, I'm going to multiply by 8. If I shift again, I'm going to multiply by 16. So how can I get 9A? I can do 8A's. That's very easy. So if I do 3 shifts, so 3 shifts, I'm going to get 8A. So if I have A, original A, after 3 shifts, I'm going to get 8A. So how can you get 9A? That's very easy, right? So all what you have to do, you have to save the original value somewhere. This is the original value. And then you have to shift it 3 times. After you shift it 3 times, you're going to get 8A. And then you can add this one to get 9A. Is that clear? Let me give you example. If I start with number 2, okay, this is register A, then the result, the correct 9A should be 16. The correct, should be 18, right? If it is correct. Let's see how it works. Number 1, I'm gonna store 2 somewhere, and for example, register B somewhere. So I'm gonna store the original value. Then I'm gonna shift A. So now A should be 4. Another shift, A is 8. A is 16. So now this should be 8A, right? After 3 shifts, you are gonna get 8A. If I add this one here, I'm gonna get 18, which is 9A. Okay, any question? This one question in the lab, okay? The other question in the lab, and this is somehow interesting, and here, I told you in the lab, you are gonna need to check some bits and set and to check and set or clear. You need it here. I'm gonna tell you how. I'm telling you, I wanna do rotate like this one. Remember, this is not our rotate instruction. Our rotate instruction, the carry is in the loop, right? So this is the instruction we have. I'm telling you, I want to do something like this one. So I want to get the carry out of the loop. Okay, so I want to do something like that. Okay. So how can we do that? Okay. So the way you can do it here, number 1, you can shift. So once you shift, you put here a 0, you put 0, and then the first bit here is going to go to the carry. Okay? And then you have to copy this bit here. Copy. because you know how this one works? The way this one should work, I have to shift with this bit. So this bit has to come here and I have to shift with this bit. Okay, but if I use shift is going to shift with 0 all the time. So I'm going to use shift and then I'm going to copy the carry to here. If the carry is 1, I'm going to put 1. If the carry is 0, I'm going to put 0. How can you copy the carry? That's exactly what I explained. I'm going to check the carry. If the carry is 1, I'm going to write 1 here. If the carry is 0, I'm going to write 0 here. How can you check the carry? That's very easy. You don't need to use branch of clear. Be careful. Branch of clear, branch of set. This instruction I used if you have a byte and you want to branch if some bits in these bytes are clear or set, right? But if you want to check the carry, you already have 2 instructions. Just use them. We have here an instruction. I don't remember. I think B, branch if carry is clear, right? And we have branch if carry is set. So I have 2 instructions here. So after you shift, ask the carry. So if the carry is clear, go to somewhere to write here 1. If the carry is set, go to somewhere so that you can write here 1. 1 here write 0. I'm sorry. So if the carry is clear, I'm gonna write 0. The carry is set, I'm gonna write 1. Okay. And to write 0 or 1, I already explained it many times. How can you write 0 or 1 in 1 bit? Okay. Any questions? Bit manipulation. Any questions? Let's come to stack. Okay. So I'm very close to end this section, this chapter. I think maybe next, for sure we are going to end. I think we should be able to finish this chapter in next lecture. And if we have time, maybe I'm going to start the chapter 3 if I have time. But let me show you what I did so far. So what I did here, I already explained data transfer instruction, arithmetic instruction, branch and loop instructions, shift and rotate, and then also this can be together logic operation. Also, can you manipulate some bits and so on? How you can check some bits? Okay. Only two sections are left. Very easy section. Number 1 is stack, and I already in the last lab I told you a stack is going to be very useful in some cases. Okay. Now I'm going to give you details. And then also, how can you make a subroutines here? Okay, so and this will be the end of this section. Here I give you, in the end here, I give you some advice about finding error. What should you do? What are the very common logic errors and things like that. So, okay. How can you write a program? So it's just some general advice. But let me start with stack. What is a stack? What is a stack? Okay, let me here. Okay. Look at the definition here. Stack. A part of the memory that is reserved for a special purpose. Okay. So far, I told you until now, I told you our memory, this is the new stuff I'm going to teach. So far, that's what we have been, that's what we are doing so far. I told you we're going to start from 1000, starting from location 1000. We're going to write our data, right? That's what we did, starting from 1000. Also, I explained, starting from 4000, I'm going to write our code. Our program should be here. Our machine code should be here. Our data has to be here. This is what we have been doing so far. Is that okay? Now, now I'm going to talk about memory. Now is going to be divided by 3, not by 2. So now I'm going to divide memory by 3. A part of the memory is going to be for your data, a part of your memory is going to be for your program, and a part is going to be for stack. Is that okay? So what I'm going to explain right now is your data will start from 1000 and your data has to go this way. Okay? Our stack, we start from 4000, but it's going to go up this way. And hopefully they don't meet each other to the stack. Okay? So the data I start from 1000, and then I'm going to use the data this way. The stack, I'm going to start from 4000, and every time I store data in the stack is going to grow. It's going to grow this way, it's going to shrink this way. Okay? And if your program is correct, they should not meet each other. Because if they meet each other, you are going to miss in your program. okay, you are gonna make a mess. Okay. So your memory, there should be a separate section for program, a separate section for data, a separate section for stack. Okay, there should not be overlapped. If there is overlap, your program is gonna make a mess. It's not gonna work. Okay. So you are telling us stack is a part of the memory. It's a part of the memory. You are gonna use it for stack. Is that right? Yes, it's right. So what is the catch? What is the new stuff here? I'm gonna tell you what is the new stuff. How it is different from what we have done. I already taught how can you read a byte, how can you write a byte using load, store. We already did that before, right? So how stack is different. I'm gonna tell you how stack is different, and then also I'm gonna explain how we are gonna use it, okay, or how it is useful. Very useful, okay, I'm gonna tell you how. Number one, in stack, the way we read or write is different from what we did before. What we did before, we call it random access. Random access means, number one, you have to tell me which location. What we did before, if you want to read or write memory, you have to tell me, number one, which location. You have to tell me which location, right? Number two, there is no specific order. So for example, I can read location number 1 and then location number 10 and then 5. So there is no specific order. I didn't tell you that you have to start from 1, 2, 3, 4 and then until you reach to 10. I didn't say that. That's why we call it random access. So random access. So this is the way we used before. How can you look here, guys? When I tell you stack is a part of the memory, what it means? It means it's a memory. It means all what we have to do is write to the memory, read from memory. That's similar to what we did before, right? It's a memory. We're not going to do something else. We're going to store data, and also we're going to read data. That's it. But we're going to do that in a different way from what we did before. But it's still memory. It's still memory, okay? But we're going to do it in a different way. How it is different way? That's what I'm explaining now. What we did before, we call it random access. Random access means, number one, you have to give me the address, because in stack you don't need to give me address in case of stack. I'm going to tell you how. This is a one difference. Okay, two differences between what we did before and between what I'm going to do in stack. The first difference is what we did before. You have to tell me which address. In stack, you don't need to tell me which address. That's number one. Number two, here there is no specific order. So I can read location number 10 and then I go to location number 7000. There is no specific order. In stack, no, there is a specific order. You cannot read any data randomly. This is what we have. This is how stack works. Last data in is the first data out. The last data you write to the stack is the first data you get from the stack. So it's not you can read any data. No, it's not random access. Okay. So the last data you write to the stack is the first data you read from stack. So last in, last out. So the best way to teach stack, or this is usually how the people teach it. Let me show a picture here. It's like if you have a stack of plates. Can you see this stack of plates, guys? Okay. So if you want to take a plate, which plate you have to take? The last one, right? The one at the top here, right? Okay, for sure, you shouldn't take one from here, right? So if you want to take one plate, usually you have to put the one on the top, right? If you want to put one plate, you have to put the one on the top. You can think a plate like a data, plate here like a data, like a byte, like a word. Is that okay? This is exactly how it works. So we have something called top of stack. Top of stack. If you want to write, so I have to write on the top of the stack. If you want to read, so I have to read from the top of the stack. Is that okay? So I cannot read this one. I cannot read this one. Okay. It has to be in order. It has to be in order. Okay. And someone can think, yeah, but it's not useful. Why? What? Before it was random. I have freedom. I can read whatever I want to read, right? But now, no, it has to be last in, last out. Is it bad? Is it disadvantage? No. It is okay because this is going to be used this way. It's okay for its, how are going to use it for its functionality? You get what I'm saying? So for, yeah, it looks somehow weird, but when I explain later how we are going to use a stack, you will see, yes. So it is designed this way to fit what's going to do. Is that okay? So there is something we call top of the stack. So every time you want to write, you have to write on this top. You have to read in this top. Is that okay? And this top of the stack, its address is stored in the register stack pointer. Now, you remember before I told you we have something called a stack pointer. I'm not gonna teach it now because it has a special functionality. We're gonna use it in a stack. Okay. So the top of the stack the address of the top of the stack should be pointed by the stack pointer. That means if you wanna read from the stack, I'm gonna read from the location pointed by the stack pointer. If I wanna write, I'm gonna write at the location pointed by the stack pointer. So the stack, and every time you read or write, the stack pointer is gonna move up and down. You got what I'm saying? Because it changes, okay? That means I told you we're gonna start here from 4,000, okay? And then we're gonna go this way for code. We're gonna go this way for stack, okay? That's what we're gonna do. And also, we're gonna go this way for data, starting from 1,000, okay? To do that, I have, in the very beginning of your program, I have to initialize the stack pointer with 4,000. So I have to say load S stack pointer, okay, with the number 4,000. So in the very beginning, the stack pointer is here, and now the stack is empty. I didn't write anything. The stack is empty, and now after that, I'm gonna write, for example, 3 in the stack, okay, and then stack SP is gonna move up this way. If you wanna write more information, for example, F2, stack pointer is gonna come here. So every time so we start from here. Every time you write something, the stack pointer is gonna go up this way. So the stack pointer is moving from a big address to smaller address. That's why every time I write, I have to subtract from the stack pointer, because that's how it is designed. Stack pointer is gonna move from here to here. Okay, so every time I write, the stack pointer is gonna be shifted up, subtracted. So the stack pointer should have, it's a pointer. Don't be confused. The stack pointer is a pointer, similar to pointer X, pointer Y, similar to the PC program counter. It's a pointer, but this pointer is gonna tell me where is the beginning of the stack, where is the top of the stack. Why I need the top of the stack? Because if you wanna read, you have to read from the top. If you wanna write, you have to write on the top. It's not anywhere, okay? So every time I write, if I write something, so the stack pointer has to go, the address of the stack pointer is gonna go this way. Is that okay? Every time I read some value, the stack pointer has to come this way. Okay, so every time I write, so the stack pointer should be decremented. Decremented by 1 if you write a byte. It is decremented by 2 if you write a word. Okay? Same thing, if you read something, okay, so the stack pointer has to move this way. I'm gonna give you details, but for now, let me, I like to do it using these boxes. So let's see this way, okay? The stack pointer is here. Now the stack is empty. The stack is empty, okay? This one is pointing at 4,000, okay? Pointing at 4,000, okay. Now, I wanna write this box in the stack. I wanna, imagine every box like a byte. I wanna write this byte in the stack. Is that okay? So what's gonna happen, number one, a stack pointer has to be decremented by 1. And then I'm gonna write the byte in the location pointed by the stack pointer. Is that okay? Then, that's why, I know some students are confused, that's why I started from here. Here is a code, there's a code here, because I'm not gonna write here. Once I started from here, once you write, so I'm gonna decrement it by 1, and then I'm gonna write. Anyway, so now the stack pointer is pointing here. This is the top of the stack. So if you wanna read, I'm gonna read this way. If you wanna write, I have to write on top of this one. Okay? So if I write another byte, so I'm gonna write 1 here, and stack pointer is gonna come to here. Automatically, you don't need to do it. Just once you read or write, stack pointer are updated automatically. You don't need to write an instruction to update the stack pointer. Same thing. Now the stack pointer has 3 bytes. Stack pointer is here. Stack pointer is here, okay? Now, what if I want to read a byte? I'm going to tell the stack, please stack, give me a byte. Again, when you write or read the stack, I'm not going to tell the stack which address. I'm not going to take, there's a big difference between how we used the memory before and how we are going to use it now, okay? How we are going to use any stack. So here, I'm going to tell the stack, please stack, give me byte. So what stack is going to do, it's going to give me the byte pointed by stack pointer, right? And then it's going to increment the stack pointer. Okay, now this is my top. This is the new top now. If I read this byte, same thing. If I read this byte, the same thing. If I read this byte, the same thing. Okay? You understand what I'm saying, guys? Any question? Okay. Now I explained the concept. Number one, this is very important. In a stack, you don't need to tell me which address, just tell me read or write. This is number one. Number two, the way stack is done, the last byte I wrote the stack, this is the first one I'm gonna get from the stack. Okay? The last plate I'm gonna put is the first one you're gonna get. Okay? So if you have this data and then you write this data, so this one is the last one I stored in the stack. When you read, I'm gonna read this one first, and then I'm gonna read this one, and then I'm gonna read this one, and then I'm gonna read this one. So who's gonna come first is the first one that's gonna be get out. Okay. So, and what I explain now, how can you write bytes? So same idea, you can write words. You can write the stack to words. It's the same idea. The only difference is the stack pointer is gonna be decremented by 2. And then you're gonna write 2 bytes. It's the same idea. Or, so for example, if the stack pointer is here, so I'm gonna read a byte pointed by the stack pointer, I'm gonna read a byte, and then I'm gonna increment by 2. That's it. So it's the same idea, but I'm gonna increment by 1 if it is a byte, or 2. I'm gonna give you more details. So that's what I explained. Your stack has to grow this way, your data has to come this way. Okay, so the stack is gonna grow this way. Again, this machine, they just execute whatever they tell them to do. They don't think, they don't have minds like us, okay? That means it's possible to make mistakes. If you write too much data, you are gonna overwrite your stack. And you are gonna make mess in your program. That's true. That's why programs crash. Sometimes they crash, right? Or if you push too much, if you write push here, I use the word to push. Because when we write the stack, as I'm gonna explain now, when you write the stack, we don't use the word write. We use the word push. Push means you write to the stack. Is that okay? That's the word we use, push. When you read from a stack, usually we don't use the word read. We use the word pull. So two words we're gonna use. Push when you write to the stack. Pull when you take from stack. Okay? So it's read, actually it's read and write. But we don't use the word read or write, we use push and pull. Okay, anyway. So you have to be careful in your program. You have to make sure you don't write too much data. You have to make sure you don't write too much data to the stack or write too much data here so that they can overlap with each other. You have to be careful about this, okay? And I think for our programs, if we make it this way, most of our programs, this memory will be enough. But for sure, if you do bigger programs, it may not be enough, and maybe I need extension. I need a bigger memory. Okay, but for our programs, we're not going to use too much memory, so I think we should be okay. Okay. I remember something happened before. I can explain it quickly. One student came to my office and he told me, look, Dr. Mahmoud, the program now is working. Is that okay? But if I add any instruction, look, if I add one instruction, crash, it doesn't work. Any instruction, but now everything is okay, now it works. If I add only one, any instruction, it's not gonna work, okay? When I looked at the program, the reason was the stack and the code was at exactly the border. So his code was this way. This is the code, and the stack you start from here and you push until here. Okay, so you're gonna use all the space from here to here. Okay, that's why it was working. But if you add only one more instruction, the stack is gonna override the code, so it's gonna make a crash. Okay, that's why we had this problem, because before I give the students the freedom to put the stack anywhere, data anywhere, code anywhere in the memory. That's why we had a problem like this one. That's why later I asked the student, no, this stack, this goes code this way, this go stack this way, data this way. So okay, but before I give the students the freedom. So what he did, for example, he started the code, for example, from 3000, and here he started from, for example, whatever 4000 in the memory. So we can push too much, he write too much, so they meet each other. So what happened when I push, I change the machine code. What happened when you push? Pushing means again you write to the stack, write to the stack, write to the stack. He changes the machine code, and when the program came to this instruction, the program tell him error. This machine code is not correct. But anyway. Oh, okay. Okay, we got to show next time.